My name is Tuan. I come from the meeting area Sofia, France. So today I'm glad to be here to present my PhD work. The title of my paper in this conference is Checking the Compliance of Business Process in Business Process Life Cycle. So today is the outline of my presentation. I will give you some introduction about my research direction and some quick analysis about related work and our proposed solution and some conclusion. So, as you know, in general, every organization has three main spaces. So, labor space, business process space, and compliance space. In business process space, the business process modeler will create new business process or modify the existing process of an organization. In labor space, the domain expert will define and create the set of business rule or regulation. And the problem is that how to checking the compliance of business process with a set of business rule in an organization. So, in this paper, we propose an ontology-based approach for checking the compliance of business process automatically. So, when we check the compliance of business process, what dimension we should consider? So, here is a figure showing some dimension we have to check when we do that. For example, so you can see we have to consider about some scope, the order, the occurrence, the information and result, the time of task in the business process, and we have to consider also the life cycle. So, what's the life cycle phase we can check the compliance of business process for in the design time, in the runtime, execution time, or after execution. It means that the backward checking. So after study some related work, some most related work and most citation work about the domain, we realize that there's no work can check the compliance of business process during three phases of business process life cycle. This means that at design time, during the runtime, and backward checking is after execution. So we propose an ontology-based approach for checking for doing that in three life cycle, three phases in the business process life cycle. So, after studying most important publications in this domain, we made some research questions in this paper. So, what part of the business process life cycle our research approach can apply, and what kind of rule our approach can cover, and how to adapt our solution with existing business process definition language, for example, BPMN, UMLs, and the system existing. So I will show you just the sketch of our solution. So you see, we have two things to consider in our apparatus. The first, the business process modeler can use the BPMN, for example, to design to design their own business process by a business process editor. So for checking the compliance of business process with the business rule, automatically the business process must be represented in the machine understandable form. So in here, in this figure, it's the business process model based. Actually, it's a business process ontology for to represent reasoning process. I will introduce in more detail in the next section. And on the other hand, for the business rules, we propose also an approach for translate the SBPR by a business rule editor. So the rule will be translated into another ontology for checking the consistency of the set of business rule, and before checking the companion of business process with the business rule. So after having two cloud base, this means in our part we use two own ontology. After having two consistency ontology, we will propose an approach for integration of two cloud base for checking the companion of business process and business rule. And after that, we will propose an interpreter for interpret the model, the consistency model to a language, but we will not present in this paper. So, for answering the second research question, what kind of business rule we can cover in our process? So, with the category of business rule, we try to cover 5 types of business rule. So, integrity rule, derivation rule, reaction rule, corruption rule, transformation rule. So, you can read more in my paper. And here is the structure of our business rule ontology. So it's in the business rule cloud base. We will have 2 layers. The meta layer is in the box in the ontology. We will have many concepts in the domain and the action, and we use property for define the integrity rule. And the fact layer. The fact layer is the set of individuals. We will define the derivation rule, reaction rule, corruption rule, and derivation of reaction rule. So we use a semantic web rule language for define 5 types of business rule. It's about the business rule development. So. And with here you can see the structure of business process ontologies. We have also 2 layers. The meta layer is in the debugger inside an ontology. We will define many concepts. Here is an ontology. We define the concept about the pertinent. If we want to use the pertinent for model checking. For checking the correctness, the structure, the correctness of the business process. And the business process instance actually is a set of individuals in this ontology. So before checking the companion of business process ontology, we use the inference engine for checking the consistency of this ontology. It means that there's no syntactic error and there's no semantic error in this ontology, and we can check this for checking the companion with a set of business rules. And here's so you can see we use an inference engine for reason on our cloud base. For checking the consistency of business process and the consistency of the set of business rules before integrating both business process and checking the integrated node base. It means that with our process we use the reasoning for checking the consistency of system by the ontology reasoning. And here's how we integrate a true ontology inside one ontology. And for apply for applying the reasoning rule with a reasoning process instance, we will define two concepts inside two ontology is equivalent. You can see here, I just give some assumption. In the BPO, transition is equivalent with the concept class in the reasoning rule ontology. So at that time, when we do that, all the rule in the reasoning rule ontology will be applied for the every instant, transaction instant in the reasoning process ontology. And for our implementation, we use the palette reasoner for checking the consistency of three chronic base. So, conclusion, in this paper, our contribution are proposing a method for representing and implementing reasoning process and regulated or regulatory and reasoning rule or laws. And we propose an ontology-based approach for checking the semantic correctness of reasoning process. It means at design time, when someone designs a reasoning process, it must accord with the rule inside a set of reasoning rules, predefined rule. And we're building a methods for reasoning process compliance checking is about it's an ontology-based approach for checking the compliance of reasoning process automatically by using the ontology reasoning. And our perspective, we continue to research about another scope. In this research, for example, so the location, it means that where you can execute the task is must follow the rule defined, but there's no team in this research direction can do it until now. And one of the difficulty in this approach is the performance, because using the ontology reasoning, sometimes it takes a long time if you have a big ontology a big set of reasoning rules. So we try to optimize the performance reasoning. And for another thing is with our project, we try to build the decentralized execution model for our project. So thank you for the attention. And please, next question.
Thank you. Okay, well, I have many comments.
Yes.
Okay, let me start from the first. So can you go to the first diagram?
Yes.
Well, when you use a picture from somebody else, use the source. So that picture was in, I think, in my 2007 paper,
Yes.
or in 2006.
Yeah.
So, well, the second problem is, the second issue is, well, you said that no approach is able to handle all steps in the life cycle. This is not correct. So essentially, the model we propose is able to check whether a process is compliant at design time, runtime, and overall. Then the other problem I've seen is, well, it's not completely clear to me what you want to do with ontologies. The first problem is that, if I understood correctly, you want to represent norms as well, not just generic business rules. And then you propose to use ontologies, so essentially first-order logic. And then there are very well-known results back to 1990s showing that, well, if you just represent norms using first-order logic, you're going to fail. You're not able to represent norms in the proper way. And then that is also the problem in approaches such as CFLO by, what's the name? I don't remember. So in the CFLOs, they try to use first-order logic to represent the different elements. And again, they are not able to handle full compliance because they are not able to represent properly norms. And then again, I don't really see what's the novelty, what has not been already done. You're just using some slightly different techniques, But essentially what you propose is completely, it's not new. It's already been done.
Yes, I understand. There's something, because it's a short time, I cannot present in my paper. So here we do with our solution with the business process better. Actually, we use the model checking is pretty better. So it's proposed by supervisor, and we will check the consistency of the model of business processor by this code base, and we can check the consistency of business rule by business rule clause base, and after that we can integrate. Because I raised some bit about C law, but they did not propose how to integrate two model. It means that the model of business process and the model of business rule, how to integrate it and how to check the compliance.
Well, so you want to check whether a business process is compliant, right?
Yes.
With a set of rules, right? This is the problem you have. Well, that issue has been done. And again, in general, you cannot use just predefined model checkers. If you just use the standard model checkers, you're going to get wrong results. And we proved it. You can integrate. What you can do, you can represent a set of all possible traces and update. If you just do model checking, there are some techniques where essentially you can model the processes as in some languages. Typically it's done in temporal logic. You represent the rules in temporal logic, and then you use off-the-shelf model checkers, and then if you do that, you get wrong results. If you use first-order logic, again, you will get wrong results. The solution is just to use other logics where you have the proper representation of norms, so you really use a logic for the only concepts. Then you might consider the set of traces, and then you can check for compliance, and that's what we propose. And then for the complexity, we study the complexity. We prove that the problem is, in the best case, already NP-complete when you consider languages for representation on rules which are polynomial, and then the complexity is by the business processes. If you add languages which are more complex for the representation of rules, then the problem is much, much worse. No.